Okay, now let's talk about the third and the fourth problem. These are a little more tricky-ish, but they make sense. Okay, so the third problem I can have is that I have fluid in my alveoli over here. Okay, I make so much mess. Okay, that looks better. That's cleaner. Okay, I have fluid over here, which is here. And another thing would be that this alveoli, it collapses. So it's the collapse of alveoli. And once we talk about all four, I will talk about how it looks on X-ray, because that's the first thing that they do at the clinic or at the hospital, right? Look at the X-ray and try to guess. Because here I'm talking about what the problem is and how it will appear. But in real life, you hear or see these, the X-ray or the lung sounds, and then you try to guess what's really going on inside, right? So yeah, that I will talk in the end. And also, you see how I'm writing it as if you were writing your notes and if you were in class or just taking a quick notes on something. So when you're watching this, I would encourage you to even draw on a paper, pencil, or whatever notes, whatever you use for your notes, and draw it and write it like this, so it becomes more reinforced and you actually remember as if you made this and you taught this. Okay, coming back. So what do I call, or what do we call when we have fluid? When we have fluid in our alveoli, we call that consolidation. If you hear the word consolidation, that's the main word. You can also say alveolar consolidation, lung consolidation, lobar consolidation. But what does consolidation mean? It's the fluid in the alveoli, okay? Whether you name it alveoli or call it a lobe, a part of the lung, or call it the whole lung, whatever. But it means the fluid in the alveoli. That's the main thing we should remember. Okay, and then the last one is the collapsing, right? When the lung collapses, and I will talk about why it collapses, it's called atelectasis. So A-T-E-L-E-C-T-A-S-I-S. Okay. First, let's talk about what kind of sounds are there going to be, and then how all four of them would appear on an X-ray. Okay, how will I get fluid in the lung, right? So there are multiple reasons for these things to happen. I'm giving like the most common or a general example of each. There's more to it too. It's just for simplicity's sake, I will keep it to one common example. Okay, how you can get fluid in your lung? Let's say the most popular one is you have this bacteria that came in, right? When they came here, then your immune system over here realize, oh, that's a invader, a foreigner, let's go wage a war against them. So when your immune system wages a war, and actually I forgot to mention, in here in your interstitial space or the parenchyma is where the blood is, okay? And the immune system is coming from the blood, so oozing out into the alveoli, waging a war against them, trying to kill it, and all this destruction going on, that will make, okay, let me erase it, that will fill your lung with the fluid. So it's not really the whole blood coming out. There could be when you have the hemorrhage, the rupture of the vessels, that the blood comes out too. But in this example, when it's trying to fight the invader, a bacteria, a pathogen, it's usually not the whole blood, but part, like a filtered blood coming out, okay? So that's what that would happen over here. And we hear this word pneumonia a lot, and that's exactly what's going on in here. And we say that for the diagnosis of pneumonia, we do need to see consolidation on X-ray. And we will see how it should appear on X-ray. I'll just do a description, no photos. But so that's the example. How will you get your alveoli filled with fluid? Okay. And then the fourth one is the atelectasis, which is the collapse. How will the lung collapse? One common example would be, let's say I have, let me erase these, just that. Okay, foreign body, right? A kid ate something that went and stuck right there, okay? So it will block air from going in and air from coming out, okay? How will the lung collapse? If the air cannot go out, this air will actually go into the bloodstream and leave eventually, and that will make it shrink. So this is one example. There are a lot of atelectasis example, but I'm taking this one so I can talk about what's going on here in terms of how the sounds will be. Okay, so that's that. Okay, I'm just cleaning up. All right, so when you have fluid in place of air, what will happen to the sound? You're trying to hear the breathing sound. Actually, let's do this one last because atelectasis is simpler and quicker explanation. There's supposed to be air that I'm supposed to hear. There is no air, so I am gonna hear no air or really little air wherever the atelectasis is happening, right? Same thing, I'm trying to feel the vibration. There's no air going in and out, so I have no vibration, okay? And then I'm trying to check the emptiness, right? The emptiness was because of the air. Again, no air, so it is going to be dull, right? Okay, so the fluid consolidation, that's the interesting one. For this one, I'm going to come back here and put the fluid. Okay, so there are two things that I like to think about. So we say normal lung sound is vesicular. So normal is vesicular, and what we're saying is that this is the sound that we hear at the alveolar level, because there is another, and this sound is continuous. Like if you breathe in and out, I won't hear the division, the breathing in and breathing out. But if you hear over here the bronchial sound, that would be where you hear the breathing in and out divided. So that's this sound, the bronchial sound that we hear at the upper airways, at the bronchial level. So we hear inspiration and expiration separately. So when I'm putting my stethoscope, I'm going for the normal vesicular sound, which is the sound that I should hear at the alveolar level. Okay. And this one actually we can divide it in two things. Because since we are talking about two sounds, there could be two versions of each, right? The bronchial, if that's normal and if that's abnormal, and then vesicular, if that's normal and that's abnormal. But we can just talk about it in this category. That's fine. So, but right now I'm going to talk about the alveolar level because that's what the original problem was. There is an explanation for this one that I will just mention it. I'm not going to write it down. Okay, so what will happen to the normal vesicular sound that I want to hear? There is fluid in here. So the normal vesicular sound is absent actually, right? But what I will hear, okay, and also if you think about it, the sound would be loud at the beginning and then it keeps getting smaller as it goes down, right? So I'm not going to be hearing the small sound, the vesicular sound that I'm supposed to hear, but this solid becomes, it will actually conduct whatever is over here. It will end up conducting and I can still hear it. So what I will hear, first of all, this becomes a conductor. So it's not a barrier. Unlike when we have it in the pleural space, that becomes a barrier. Here, it's not a barrier, it's a conductor of whatever sound was here before. So, and since sound gets from loud to low, what I will hear is I will hear a louder version of the sound. So it will actually be increased. Same way, when I put my hand for tactile fremitus, I'm going to hear a louder version of the sound because this part became conductor. Wow, I have made so much mess. Okay, so this part became conductor, but I'm hearing the louder version that was right above. So this will also be increased. And then we talk about the resonance, right? So now that was about the emptiness, right? But over here we have it filled with fluid, so there is less emptiness, so it has to be dull. Okay, so and then let me come back and talk about this part, or let me do it in the next part.